I want to show you how to find the zeros of a polynomial function. The fundamental theorem of algebra states that if you have an nth degree polynomial, then you will have n zeros. So some of those zeros may be rational, irrational, or complex. And I put rational and irrational in red to show you that you may see the word real. So I'm gonna put real here. So rational and irrational refers to the real zeros, and sometimes you're going to have complex zeros, which of course may involve the letter I. Now, what is a root or a zero graphically? I mean, what does it mean graphically? So it says if a polynomial has n zeros, will its graph have n x-intercepts? So when we're referring to zeros, we mean we are setting y equals 0. So this y here, so instead of y equals x cubed minus 4x, it will be 0 equals x cubed minus 4x, and I'm going to show you how to factor that in the next slide, but I want to show you what it means to have zeros graphically. So basically it's saying, when is y 0 on this graph? When is y 0? Notice these points here. These points here. So this point here looks like, let's see, this is by ones, 2, 3, 4, 5, 1, 2. So this looks like -2, 0, right? The y is 0 there, and this is 0, 0, and this is 2, 0. So that's why we call them zeros. This is when y equals 0. And notice here it says in this example the degree n equals 3, and we know what the degree is from looking at the original problem and looking at the highest exponent. 3 is the degree. It says, and if we factor the polynomial, the roots are x equals -2, 0, and 2. Exactly what we got over here. -2 here, 0, and 2 are the zeros for this polynomial function. We can also see from the graph that there are 3 x-intercepts. So in this case, our degree was 3, and we had 3 x-intercepts. So let's go to the next slide and figure out how can we get those zeros just from factoring. Okay. It says we can find the roots or zeros, and roots and zeros refer to the same concept. We can find the roots or zeros of a polynomial by setting the polynomial equal to 0 and factoring. So again, setting the polynomial equals 0. So f of x, of course, is the same thing as y. Okay. Same thing as y. And all we really need to do is really set f of x to 0. Okay, so instead of a f of x, you can put zeros there. And then you will factor your polynomial function. So x cubed minus 4x, the GCF, greatest common factor, always comes out first. So GCF is x. They took an x out, and what's remaining? X squared minus 4. This x squared minus 4 is called a difference of squares. So the factors for the difference of squares is x plus 2, x minus 2. And you can always multiply all of this back to see if you get back x squared minus 4, and then multiply x times x squared minus 4 to see if you get back x cubed minus 4x. So now this is in factored form. So this is what they call linear factors here. Linear referring to the degree being 1 for each x. So x, this is to the first power, this x plus 2 is to the first power, this x minus 2 to the first power. So these are called linear factors. And this is the complete factorization here. Now, if we would set each one of these x's to 0, we would get the roots. Okay, so we set x equals 0, we get the 0 here. Then if we set x plus 2 equals 0 and solve for x, we'll get x equals -2 here. And then if we solve for this x minus 2 equals 0 and add 2 to both sides, we get x equals 2. So this is how you would get your roots or your zeros. Okay, roots and zeros refer to the same thing. Alright, so that's how you find your roots and your zeros algebraically. But again, go to the last slide. To find the roots and zeros graphically, all you're doing is figuring out what are the points that cross the x-axis. These points are also referred to as your x-intercepts. Okay, that's when you substitute 0 for your y and solve for x. Real imaginary roots. So it says just because a polynomial has n complex roots or zeros doesn't mean that they are all real. Okay, doesn't mean that they are all real. So basically what they're saying is sometimes you can find zeros that have an I involved. Okay, so it doesn't mean that you're going to always have a nice little number like 2 and -2 and 0. Sometimes your zeros are going to end up being 3i or I square root of 2. So those are not real. So let's look at this graph here. Just from this graph, what do you think is the 0? Or where are the zeros here? So again, if you look at the x-axis, this is obviously a 0 because it crosses the x-axis here. And this looks like -1, 0. Right? So -1, 0. But according to this polynomial function here, the degree is 3. So we're supposed to have 3 zeros. Right? But we only see 1. Right? So this tells us that even though the degree is n equals 3, there is only one real x-intercept, and that's -1. The other two roots must be imaginary. The other two roots must be imaginary. So it involves an I. And of course, we can't determine roots that involve I graphically. Alright, let's learn how to find root zeros of a polynomial. It says if we cannot factor the polynomial but know one of the roots, we can divide that factor into the polynomial. The resulting polynomial has a lower degree and might be easier to factor or solve with the quadratic formula. So let's look at this. F of x equals x cubed minus 5x squared minus 2x plus 10. And one root is given to us. It says one root is x equals 5. So if you know that one of the roots is x equals 5, you can either use long division or synthetic division to divide that root and see what's remaining. Now, I usually use synthetic division. So let me just show you synthetic really quickly. Alright. So if we were using synthetic division, we'll use 5 because they gave us the root is 5. Alright. So they gave us the root. So no need to change the sign on that one. And we have 1, -5, -2, and 10. Always bring down the first number, 1. That's 5. When you multiply 1 times 5 is 5. That's 0. 0 times 5 is 0. -2. -2 times 5 is 10. 0 remainder. So this proves that 5 is actually a root because the remainder is 0 here. Now how do we write 1, 0, -2 as the remaining factor? Now we started with x cubed term here. The degree is 3. So every time we do synthetic division, our degree goes down 1 by 1. Okay, so this one right here is representing the coefficient of x squared, plus this 0 represents the coefficient of x minus 2. So what's left is just plainly, we have an x minus 5 factor already from this right here, but we also have remaining x squared, and you don't have to write the 0x now. Just put x squared minus 2. So that's what's left. And notice this is what they have over here, that x squared minus 2 times this x minus 5. Okay? So if you multiply x minus 5 times x squared minus 2, you would get x cubed minus 5x squared minus 2x plus 10. Now notice that this is not completely factored, because you still have an x to the second power. So if you were asked to provide the complete factorization, you will also have to factor x squared minus 2. Okay? So let me erase all of this. It says we can solve the resultant polynomial to get the other two roots from this x squared minus 2. How did they get the square root of 2 and then minus negative? So of course we had x minus 5 times x squared minus 2. You can use the quadratic formula for this, x squared minus 2, where a is 1, b would be 0, and c would be negative 2. Or you can simply just, if you're comfortable with this, you can say x squared minus 2, set that equals 0. And then what would you do to solve for x here? You would add 2 to both sides. That cancels. Then you have x squared equals positive 2. And then what would you do? You do the square root of both sides. And when you do the square root of both sides, you need to put plus minus. Alright, so the answer is x equals plus or minus the square root of 2. So that's where the positive square root of 2 came from and the negative square root of 2 came from. In conclusion, the roots of f of x equals x cubed minus 5x squared minus 2x plus 10 are 5, they gave us 5, but also the square root of 2 and negative the square root of 2. So again, 5, the square root of 2, and negative the square root of 2. Now, let me show you how to find the possible rational roots of functions, but you are not given a possible solution. So, what if you weren't given a root to start with, and they just give you a function and you were asked to find the roots? Well, you will first start off by finding the possible rational roots, which would bring me to something called the rational zero test. Alright, it says that the polynomial function has integer coefficients. Every rational zero of f has the form p over q, where p and q have no common factors other than 1, and p represents the factor of the constant term and q represents the factor of the leading coefficient. So these a sub zeros here, that refers to the last number over here, and this a sub n refers to the leading coefficient here. So let's look at this. G of x equals x cubed minus 4x squared minus x plus 4. Now, what do you think is the p in this situation? Again, p represents the factors of the constant term. So, in this situation, p would equal factors of 4. Okay, so plus or minus factors of 4. What are the factors of 4? Plus or minus 1, plus or minus 2, plus or minus 4. Divided by q, which are the factors of the leading coefficient. So what is the leading coefficient here? Coefficient is a number, not a variable. So what is the number considered to be in front of the highest, the term with the highest exponent? It is 1. So q factors are 1 plus or minus 1. Then you're going to have to divide each p p by each q. And this is an easy case because we only have one factor for q. Okay, so if you divide 1, 2, and 4 by 1, you're just going to get the same thing back. You get plus or minus 1, plus or minus 2, and plus or minus 4. So these are the possible rational, and me put emphasis on possible rational zeros of this g of x function here. Only the possible rational zeros. So this test says that all of these rational zeros, something's going to work. Okay, something's going to work. We just have to test some of these possibilities to see where are the actual rational zeros. So again, we said that possible rational zeros ended up being plus or minus 1, plus or minus 2, and plus or minus 4. And for future reference, I'm not going to write plus or minus so many times. I may end up just doing a little shorthand and say plus or minus parentheses 1, 2, 4. But this is understood as the same thing, okay? So I just write it shorthand so I don't have to write plus or minus so many times. Alright, so I'm going to test some of these out. Now, how would you test to make sure that one of these work? I like using synthetic division. Okay, so let's try positive 1 maybe. Let's try positive 1. And I'm going to put the coefficients of this function. So 1, because that's coefficient is 1, negative 4. Then what is this here? That's a negative 1 and a 4. So let's try it. So bring down your 1. 1 times 1 is 1. Negative 4 plus 1, negative 3. Negative 3 times 1, negative 3. Negative 1 plus negative 3, negative 4. Negative 4 times 1, negative 4. And then 0. Therefore, it worked. So positive 1 is a rational zero. So what do we have so far? So far, we have g of x equals, since 1 worked, how would you write this as a factor, this 1? So remember in synthetic division, we normally change the signs and all that kind of stuff. Remember that? So you would write all of your zeros as x minus whatever your zero is. So it's 1 in this case. And then since we started out with x cubed, how do we represent this 1, negative 3, and negative 4? We go down 1 degree. So it'll be x squared minus 3x minus 4. And what's so great about this is we understand how to factor a quadratic. So this is a quadratic here, right? Isn't this a quadratic? So don't you understand by now how to factor a quadratic? If you don't, go to one of my integrity sessions on factoring trinomials. Okay, so you can try to brush up on factoring a trinomial. And so either we can factor it by hand or use the quadratic formula to factor it. So we need to get all of these factors to be linear. So this x minus 1 is linear, but this is quadratic. So we got to break it up so that it's just x to the first power. So what are factors of negative 4? Well, factors of negative 4 that if you add them will give you negative 3. Factors of negative 4 that if you add will give you negative 3. Let's see, 4 and 1, but the 4 needs to be negative. X minus 1 times x minus 4x plus 1. So if I multiply this out, I will get back x squared minus 3x minus 4. So this is the complete factorization, because all of these factors are linear. So look at this second one here. F of x equals 2x cubed minus 3x squared minus 11x plus 6. So if you are asked to find the possible rational zeros, all you really need to do is do p over q to find the possible rational zeros. And then, like I did before in function g, we're going to go ahead and figure out what are the actual zeros, not just the possible rational zeros. P again represents the factors of the constant term. Constant term is just a number, so plus or minus 1, 2, 3, and 6 are all factors of 6. And Q are the factors of the leading coefficient, which is 2, so plus or minus 1 and 2. Now, you not only just have 1 as a factor for Q, but you also have 2. So every P you must divide by every Q. So let's first divide everything by Q equals 1. So we have plus or minus 1, 2, 3, 6 if we divided all of these numbers at the top by 1. But we also have to divide all of these numbers in the top by 2. So if you divide 1 by 2, you get 1/2. Divide 2 by 2, you get 1, and we already have that already, so no need to rewrite it. 3 by 2 is 3 over 2, and 6 divided by 2 is 3. We already have that possible root. So these are the possibilities here. Now, in order to figure out which possible roots are actual roots, we can use synthetic division. So what we're going to do is just choose a number randomly. I usually choose positive 1 first. So let's choose positive 1. And you're going to go ahead and put all your coefficients, making sure that you have every term. If you do not have every term, then you will put a 0 in its place. So let's write 2, -3, -11, and 6. And these are all the coefficients here. Always bring down the first number 2. 2 times 1 is 2. -3 plus 2 is -1. -1 plus -1 times 1 is -1. -11 times -1 is -12. And already I see that this is not a root, because this is not working out to be a 0 remainder. I actually have -6 as a remainder, so I know that 1 is not a root. Alright, let's try a -2. Bring down your 2. 2 times -2 is -4. It's -7. -7 times 2 is 14. -11 plus 14 is 3. 3 times -2. Finally, we get a 0 remainder. So what we have so far is we know that -2 is a root. How would you write that? You write every root as a factor by doing x minus whatever that root is. So you'll do x minus whatever root is. So it's going to end up being a x plus 2, because a minus times negative is plus. And then what do you have left? We started out with to the third power, so this represents to the second power polynomial. Therefore, we will say 2x squared minus 7x plus 3. What I'm getting these numbers here from here. All right. And then since I have a quadratic, a trinomial here, I can factor this by hand. Alright, and so there are many ways to factor a trinomial. I'm going to use the factoring by grouping method. Alright, so I'm going to go ahead and I know there's going to be f of x equals x plus 2 times something times something. Now you can also use trial and error methods. Alright, I know that the factors here must multiply to give me 2x squared, and I know the factors in these positions here must multiply to give you 3. So it's actually, because these numbers are prime, you know that there are not only factors are 2 and 1 and 3 and 1. So it's pretty easy. Well, I'm going to show you the factoring by grouping method. Is you will multiply this leading coefficient times the constant term. It'll give you 6, and you find factors of that number that will add up to the middle term, middle coefficient here, which is -7. So what are two numbers? If you multiply them together, will give you 6. But if you added those two numbers together, will give you a -7. So the answer is -6 times -1. Alright, since we found our numbers now, I'm going to rewrite our quadratic that we're trying to factor. And then we're going to put 2x squared and break -7x up into -6x minus x, because those are the coefficients we just found. I got that from here. Plus 3. So basically sort of expanded that trinomial into 4 terms. And now once you have 4 terms, there's a possibility you can factor by grouping, and that's what we're going to do here. We're going to group the first 2 terms together here and the last 2 terms together. Alright, what is the GCF of 2x squared minus 6x? It's 2x times what to give us 2x squared minus 6x? It's x minus 3. I also want x minus 3. I have -x plus 3. So how can I manipulate this to get that x minus 3? I need to factor out a -1, and that'll give me the x minus 3 that I need. So now, what is the GCF of this and this? What's the GCF? What's in common? The x minus 3 is in common. So just like every other GCF, I'm going to take the x minus 3 out, put it on the left, and put my parentheses. X minus 3 times what will give me back 2x times x minus 3? It'll be 2x. And x minus 3 times what will give me back? -1 times x minus 3 is -1. So that's why the factors are x minus 3 times 2x minus 1. So I'm going to go ahead and replace it over here in these parentheses at the x minus 3 and the 2x minus 1 that I just found. So here you have your complete factorization. Okay, the complete factorization of that original function. Now, if you were asked, what are the zeros? You would set each one of these parentheses to 0 and solve for x. For example, set x plus 2 equals 0 and solve for x. You'll subtract and get x equals -2. So that's a 0. You will also set x minus 3 equals 0. What would you get if you solve for x? You will get 3. And if you set 2x minus 1 equals 0 and solve for x, work that out, you should get 1/2. So notice that -2 was included in the list here. Plus or minus 2 was included, 3 was included, and this 1/2 was included. So out of all the possible rational zeros, only -2, 3, and 1/2 are actually. So this is a trinomial because we have 3 terms here. So let's try to use the same technique we've used for factoring trinomials. But I know this is x to the 4, but it's okay because if I put my two parentheses here, I know that x squared times x squared will give me x to the 4. What I'm really concerned about is what are the factors of this negative 27 that if I add those factors together will give me a positive 6. Is that possible for us to come up with factors of negative 27 that if we add them will give us a 6? So let's see, 9 and 3. If I make 9 a plus and make 3 a negative, that will give me the positive 6 that I need in the negative 27 when multiplied. So here's what I want you to notice from your book. So this happens to be number 51 in your book. And the instructions say, write the polynomial, right here, write the polynomial a as the product of factors that are irreducible over the rationals. Then it says b as the product of linear and quadratic factors that are irreducible over the reals. Then it says in completely factored form. State that we is in noun. This is considered to be a, the answer to a. And then it says b as the product of linear and quadratic factors that are irreducible over the reals. So real refers to rational and irrational numbers, not the I. Okay, not the numbers that will give us I. So if you notice here, x squared plus 9, if we subtracted 9 and did the square root of, we're going to end up with an I over here. So that's what they don't want you to factor that out. They want you to factor out the other factor. So keep this as x squared plus 9, but they want you to figure out what are the linear factors for x squared minus 3. So if you do x squared minus 3 equals 0, you add 3 to both sides, get x squared equals positive 3, and then do the square root of both sides, get x equals plus or minus the square root of 3. Therefore the factors are x plus the square root of 3 and x minus the square root of 3. Now it says in C, in completely factored form. So now they want the x squared plus 9 to be factored. 0, we'll subtract 9 from both sides and get x squared equals negative 9, and then we'll do the square root of both sides, get x equals plus or minus, and this is going to be negative 1 times 9. So it's x equals plus or minus 3i. So this is what they mean about complex. Okay, complex solutions. Therefore, for C, the answer is f of x equals x plus 3i, x minus 3i, x plus square root of 3, and x minus the square root of 3. Zeros. So the zeros in its entirety are negative 3i, positive 3i, negative square root of 3, and positive square root of 3.